Welcome to the penultimate video in the series leading to your Technician Class License exam. This is video number 20 out of 21. This is the last video with a lot of technical information in it. In this video, I'll discuss Ohm's law. We'll learn the relationship between volts, ohms, amps, and watts, and how to calculate one of these values if two of the others are known. These will be the final two formulas of the 5 important Technician Class License formulas. The calculations are straightforward multiplication or division. You're allowed to have a calculator to use during the test. The calculations for the test use small numbers and can often be figured out in your head. There are two Ohm's law formulas. One describes the relationship between volts, ohms, and amps. The other describes the relationship between watts, volts, and amps. It's helpful to remember what the various letters and symbols mean and what they stand for. The letter E stands for electromotive force. When you see the letter E in a formula, it means electromotive force, which is measured in volts, denoted by the letter V. The letter R stands for resistance. When you see the letter R in a formula, it means resistance, which is measured in ohms, denoted by the Greek symbol omega. The letter I stands for current. When you see the letter I in a formula, it means current, which is measured in amps, denoted by the letter A. And finally, P stands for power, which is measured in watts, but it's also only denoted by the letter P. The two equations are volts equals amps times ohms, and the other one is watts equals amps times volts. The magic circles on this page depict how to solve either of the two equations. You're allowed to have 2 pieces of blank scratch paper during the test to do your calculations on. I recommend drawing these circles at the top of one of the scratch pages at the start of the test, the EIR circle and the PIE circle. I'll show you how to use these magic circles in the subsequent slides. Each possible test question will supply 2 of the 3 numbers and ask you to calculate the unknown value. For instance, the question T5D04 asks, what is the resistance of a circuit in which a current of 3 amps flows through a resistor connected to 90 volts? The known information is the current of 3 amps and a voltage of 90 volts. The unknown is the resistance. Here's how to use the magic circle to calculate the answer. Cover up the unknown value and solve the resulting equation. So, if I want to find voltage, I cover the E, and then I know that I should multiply the amps times the resistance to get the voltage. To find current, I cover the I, and then I know that I need to divide the volts by the ohms to get the current. To find resistance, I cover the R, and then I know that I need to divide volts by amps to get the resistance. In my example, I have a current of 3 amps, a voltage of 90 volts, and need to know the resistance. I cover up the R and see that I need to divide the volts 90 by the amps 3, which yields 30 ohms of resistance. It really is just that easy. These are 2 possible test questions. In the first question, we know the amps, 0.5 amps, and the ohms, 2 of them. We want to know the volts. The magic circle says to multiply amps times ohms, which would yield 1 volt as the answer. In the second question, we know that the voltage is 2 volts and the current is 4 amps, and we need to know the resistance. The magic circle says to divide volts, which is a value of 2, by amps, which is a value of 4, which would yield 0.5 ohms, or 1/2 ohm, as the answer. Stop the video and work through these 2 questions. Start the video again when you have your answers. Here are your answers. How did you do? If you didn't come up with the right answers, go back and review this section again. So the resistance of a circuit in which a current of 3 amps flows through a resistor connected to 90 volts is 30 ohms. And the current through a 100 ohm resistor connected across 200 volts is 2 amps. Now let's go to the power equation. Just for grins and giggles, I've depicted this as a magic triangle instead of a magic circle. It works the same way. Cover up the unknown and then solve the resulting equation. In question 1, we know the voltage is 13.8 volts and the current is 10 amps. And we want to know how many watts are being consumed. I cover up the P in the magic triangle and I see that I should multiply the amps, a value of 10, times the volts, a value of 13.8, which yields 138 watts. In question 2, we know that there are 12 volts and 120 watts are being consumed. We want to know how many amps of current are flowing. I cover up the I, and the magic triangle says to divide the watts 120 by the volts 12, and we'll find out that there are 10 amps of current flowing. So stop the video and solve the questions on this slide. When you have the answer, start the video and let's see how you did. Did you multiply 2.5 amps by 12 volts and get 30 watts as the answer? If so, excellent. If not, you may want to back up and review this section again. Gustav Kirchhoff, a prominent 19th century German physicist, put together a set of 2 laws governing voltage and current. If you remember back when I defined volts, ohms, and amps, and used the water tank analogy, I said that volts get used up in the circuit, but current does not. That's the essence of Kirchhoff's voltage law and current law. In the voltage law, Kirchhoff declared that the voltage gets used up in the circuit. Components use voltage and different components use voltage differently. So the voltage across 2 or more components depends upon the value and the type of the components. In the current law, Kirchhoff declared that whatever current is injected into a circuit, that's the amount of current that will be returned at the end of the circuit. Circuits often have components in series as well as branches in parallel. If everything is in series, the current will be the same through every component. If a circuit divides, then the current divides at that junction in proportion to the value of the components in each branch. Eventually, however, all branches must come back together at the injection point, and the input current will equal the output current. This slide attempts to make clear how current flows through a circuit and how voltage behaves. Go ahead and take a moment to read it. So let's go back to the water analogy once again. The system behaves as Kirchhoff declared. All the pressure is used up, but all the water still remains. And so consequently, the water pressure, by the time all the water exits the tank, turns the wheel and gets to the collection pond, all the water pressure is 0, just as Kirchhoff's law of voltage states. The amount of water, however, in the collection pond will eventually equal the amount of water at the source. Nothing is lost, just as Kirchhoff's current law states. All right, so here are all 5 equations. 2 of the formulas deal with converting between frequency and wavelength. Remember that 300 is always in the numerator. The third equation deals with calculating the length of a dipole. Remember the cheerleader chant, 2, 4, 6, 8, who do we appreciate? The final 2 are Ohm's law and Ohm's power law. As I said earlier, if I were taking the test, after the test starts and before trying to answer any questions, I would write all 5 equations at the top of one of the pieces of scratch paper. Then the equations would be available when I needed it to make a calculation. One other note, some test questions deliberately mix units of measure. They might say how many ohms in a circuit with 500 millivolts, but the equation uses volts, not millivolts. Remember to convert everything into the right unit of measure before solving the equation. This concludes the video session on Ohm's law. Remember the magic circles. They make solving any Ohm's law question easy and straightforward. If you have any questions or concerns, please remember to bring them up in the next online class session or email them to me at rolandksmith@gmail.com. We'll see you online.